Hello students, in the given question 2 gram of hydrogen reacting with 8 gram of oxygen to give water according to reaction. Calculate limiting reagent, moles of excess reactant left, mass of excess reactant left, molecular excess reactant left, volume of excess reactant left, moles of product form, mass of product form, molecules of product form, and volume of product form. So in the single question and different type of by single statement, we will do the different types of questions. That means one is limiting reagent. What is that? Limiting reagent. So in this particular question, you observe here, they have given, which one? Two data. One is the 2 gram of hydrogen and 8 gram of oxygen. So you have to decide that when they have given two quantity, you should not go to the stoichiometric calculation. You have to go to the limiting reagent calculation. Stoichiometric calculation में क्या देगा? Reactant side they will give, product side you have to calculate. One value they will give. So now based on this question, you have to follow the stock limiting reagent calculation. The first question that they have given, what will be the limiting reagent out of these two? So before going to that one, you have to write the reaction that hydrogen H2 is going to be combined with O2. So it is going to be form H2O. So then you balance this equation. Here 2 moles of H2 and 2 moles of H2O will form. So this is the actual equation. In this equation, so as per the data, 2 gram of hydrogen reacting with 8 gram of oxygen. So 2 gram of hydrogen means, so 1 mole of hydrogen will give 1 mole of hydrogen will give 1 mole hydrogen will give 2 grams. 1 mole hydrogen contain 2 grams and 1 mole of oxygen contain 32 grams. So the 2 gram of hydrogen means 1 mole. 32 grams oxygen means it's a 1 mole. But in oxygen they have given 8 grams. That means it is, so 4 times it's less. That's why it's a 0.25 mole. So in this given data, what they have given, this one you write here. Here 1 mole given of hydrogen. Here 0.25 given. So in this case, out of 1 mole. So if you want to calculate the limiting reagent, means given mole 1 mole by stoichiometric coefficient. Stoichiometric coefficient value is the 2 and given volume is 0.25 and 1 mole. That means the limiting reagent will be, so out of this one, so 0.5 mole will form and here 0.25 mole is going to form. So out of these two, the limiting reagent, which is the limiting reagent, the oxygen is the our limiting reagent. So how many moles of limiting reagent? It is 0.25 moles of limiting reagent is formed. So the second question, the how many moles of excess reagent is left? So if you want to calculate the, before going to the excess, which one? uh, excess reactant, so you need to do one thing. So this calculation is only for detection of kaunsa limiting reagent, but how many moles are converted, into products, how we can know this? So here 0.5 and 0.25, you observe here, out of 0.5, out of 0.5, here how many moles are converted out of 0.5? Here 0.25 is converted. How many? 0.25 converted. That means 0.5 minus 0.25. This is the left, and here completely this one you can keep it like this. So here limiting reagent, here how much? 0.5, 0.25 is consumed from oxygen. From here also how much is left? 0.25, and it is formed 0.25 this side. But actual final moles, if you will observe, you have to multiply this one with the stoichiometric coefficient. So this one you have to multiply with 2, this value multiplied with 2, and here the stoichiometric coefficient value is 1, so 0, and here the stoichiometric coefficient value is 2. You multiply it, then you will get the actual moles as per the reaction, as per the given data, you will understand here. So here 0.25 into here 0.5 minus 0.25, you will get it 0.25. So that means you will get it the final volume, final moles will be 0.5. So 1 into 0, it's 0. And here how much? 0.5 moles is formed. 0.5 moles is formed. So here 0.5 mole is the excess. How many moles are there here? Better this one. Here the excess reactant left out of 1 mole, out of 1 mole. So 0.5 mole is converted into, out of 1 mole, 0.5 mole is converted into the product, and 0.5 mole is excess reactant. The moles of excess reagent is 0.5, and right, moles of excess reagent left 0.5, and which one is left? Excess reagent hydrogen. So if you will go for this 0.5 moles of hydrogen means, then how much, what is the mass of hydrogen? That means it is nearly 1 gram. How many grams here? Nearly it is 1 gram. Means 1 mole of product will give 1 mole of product is 1 mole of product, or 1 mole of hydrogen is 2 grams. Then 0.5 mole of reactant is 1 gram. Then so number of molecules of excess reactant. So the molecules of excess reactant left, the molecules, number of molecules, if you want to calculate, number of molecules equals to weight upon molecular weight into Avogadro number, into Avogadro number. So number of molecules, if you will see here, weight how much? 1 gram, 1 by 2 into weight is the 1 gram weight, and the hydrogen is the excess reactant. So its molecular weight of H2 is 2, and Avogadro number. So then it will be how much? 0.5, 0.5 Avogadro number. So volume of excess reactant left. So 1 mole of hydrogen gas, 1 mole of hydrogen gas contain 22.4 liters at STP. Then 0.5 liters of hydrogen gas containing how much? 11.2 liters. So here what is that? Excess reactant left, it's at 11.2 liters. Right. Next, moles of product is formed. How many moles of product is formed? Just here this many number of moles of product is formed. So this is 0.5 moles product. And mass of product, mass is which one? Product is which one? H2O. H2O. The mass of the product means, how you will calculate the moles formula? Moles equals to weight upon gram molecular weight. So weight, how much weight we need to calculate? Mass, that means how many moles? The mole is the 0.5, weight is the 18. So 0.5 into 18, how much moles product is formed? It is how much? How much better? This one it's a 9 grams. This mass of product will be how much? 9 grams. For 0.5 moles, it is a 0.5 into 18. 0.5 into 18, it is coming the 9 grams. and molecules are formed, if you will observe here, same formula, number of molecules ka formula, weight upon molecular weight. Weight of H2O how much? 9 grams, and molecular weight of H2O is the 18. So 9 by 18 into Avogadro number. 9 by 18 into Avogadro number. It is coming 1 by 2 only. That means it is molecules how many? Same molecule 0.5 Avogadro number will form. Next one, volume how much? So H2O, if you will see, the H2O, it is gas. The number of molecules also in the same fashion we are going for this one. So 0.5 moles. So 1 mole of H2O form the 22.4 liters, and 0.5 moles of this is also how much? 11.2 liters. 11 point how much? 2 liters volume is formed. So this is the question. So in any method if they will give, just use this follow. One thing you have to keep it in mind, just I want to tell you here. Here in this point, this particular question, so 0.5 into 0.25. So this calculation to detect the which one? Limiting reagent. After detection of limiting reagent, so you have to do from 0.5 से 0.5 से 0.25 इधर चला गया. It left over a 0 point of the limiting reagent. This limiting reagent is converted into कौन सा? As a product. Keep it in mind. So that means 0 point is converted from here to this side, means at the same time some amount, this one, the same amount will be used from which one? Hydrogen also. So how much amount? How much is limiting reagent? That much amount you have to remove. You have to remove from this one. It is that leftover amount 0.25. After leftover amount, whatever the stoichiometric coefficient value is there, that one need to be multiplied. So then you will multiply this value also. At the same time, the leftover how much limiting reagent you have to multiply with stoichiometric coefficient, and after formation from this 0.25 you have to multiply with that one also. Then you will get final exact moles. This is your actual moles, either excess reagent or formation product. I hope you understand this one. So follow this method for every question. ठीक है. Thank you.